Okay, so just to kind of clarify a few things, please hold your conversation. Yesterday, 8.4 was really about the determinant. How do you calculate the determinant? Can you do different things like number 84, solve an equation using the determinant? And then section 8.5 is really about the many uses of the determinant. So we've already done two, finding the area of a triangle and then testing for collinear points. So we're going to get to Cramer's rule, but before we get to Cramer's rule, we're going to do the 2-point form equation of a line. So this is, you're given 2 points that are on a line. Can you write the equation of the line? Yes, you can do that from knowledge that you have all the way back to Algebra 1, calculate the slope, then plug into either point-slope form or slope-intercept form, write the equation. But we can also do it with matrices and determinants. So this one's kind of building off of the idea of what we ended with yesterday, collinear points. So we're going to think about like 3 points that are on the same line, but we're only given 2 of them. X sub 1, y sub 1, and x sub 2, y sub 2. So the formula for the equation of a line, given 2 points, is given by a determinant. Little bit different from what we saw yesterday because both the area of the triangle and the collinear check had 3 points. Our first row are just going to be regular x and y. So this one you're never going to sub numbers in. You're going to leave x and y as variables, and that'll come back in your equation so that you have an equation with x and y variables, which equations of lines have. The other rows will be very similar to what we worked with yesterday. X sub 1, y sub 1, 1, x sub 2, y sub 2, 1. And think about collinearity. If you're writing the equation of a line, all of these points, the 2 points that you're given, and then any xy ordered pair have to be on the same line, so that has to be equal to 0, so that they are collinear. All right, let's look at an example. Tegan?
So when it gives us like that equaling something, what it equals is always the determinant.
Yeah, so if you had these 3 points on the line, they would have to equal 0. So that if you're thinking about yesterday, the area of the triangle is 0, they're collinear. And we're talking about an equation of a line, so we need all the points. 2 of which we know. 1 is just like the random ordered pair that sits on the line, x, y, but they all have to be on the same line. Let's look at an example here. Find the equation of a line passing through -3, -1, and 3, 5. So again, this problem looks like something you could have done without matrices, but now we're just looking at another way to do this problem. And we can work it with this definition we have for collinearity. We're going to start with a determinant. And the only difference that you have to remember when you're writing the equation of a line is you should have an x and a y in your equation, so you need to write that into your determinant, x and y, in the first line. And then it doesn't matter which point is x sub 1, y sub 1, or which point is x sub 2, y sub 2. And I'm going to leave a little bit of space here because I have to calculate the determinant, but we know that has to be equal to 0. So remember, we're trying to write the equation of the line, so we need an equal sign somewhere in our answer. So we calculate the determinant. I'm going to copy my first 2 columns. Do my diagonals. I'll get a negative x plus 3y minus 15 and then going up, so I'll get a negative 3 plus 5x minus 3y. Now, different from everything yesterday, we've introduced the variables x and y, so we don't have like terms. Those things can't necessarily be added to a single number like we saw yesterday. So think about the definition for the determinant that we wrote. This would yield for us, we'll take the blue pieces first. So negative x plus 3y minus 15, and then subtract from those the red, but remember you got to subtract all the terms. So I'm going to put it in a group of parentheses to protect them. So negative 3 plus 5x minus 3y, and that equals 0. And there should be, in each of those sums, some like terms. So now you can go through and combine like terms. Just remember when you're doing that, this negative distributes to all three terms. So I'm going to go ahead and change their signs. I'm going to make this a plus. That makes 3 a positive, 5x a negative, and 3y a positive. And then I can just add my terms together. So I'm going to get negative 6x plus 6y minus 12 equals 0. Okay, so then Sierra's thinking, well, that doesn't really look like the equation of the line that I know, so she might want to write it in standard form. So you would move the 12 over, right? Is that okay? Yeah. Either one of those is fine with me. Okay, so if you want to leave it equal to 0, that's okay. If you want to write it in standard form, like you would normally see the equation of the line, I'm okay with that. One thing to be aware of when you're like checking your answers in the back of the book, they might look at all three terms and say, hey, all three of those terms have a common factor of 6. So in the back of the book, if your answer doesn't match exactly, you might check to see if all the terms had a common factor, and you could also write this equation. Negative x plus y minus 2 equals 0. Or if you did it in standard form, you could also divide all of those by 6 and get negative x plus y equals 2. So I'm really like all of those are equations of lines. They're all acceptable. Just kind of be aware when you're checking your odds in the back of the book. If you moved it into standard form and they left it equal to 0, just move it back over so that you can check your work. Or check to see if they share a common factor. Okay? Any questions about that? Yes. Yes. If you wrote it then as y equals x plus 2, I would also accept that. That would be in slope-intercept form, right? At that point, I'm just like, you're doing more work than you have to do. And Miss Cronky is kind of lazy, so she wouldn't do that. But if you did, that's still the same equation. That's still the same line, so I'm okay with it. They're all the same line, so it doesn't matter to me. Are we okay with that? Okay, so that's that extra use. Just be really careful. I think this green area right here with the distributing of the negative on the second diagonal going up, that's going to be an area of caution that you'll need to pay attention. Okay, so let's finally get into Cramer's rule. Which is our third method to solve a system of equations. You already have augmented matrices and row operations. Get it in row echelon form or use your calculator for reduced row echelon form. You have matrix equations, AX equals B and inverses. Multiply the inverse A by B, and you'll have a solution. And then the third is going to be Cramer's rule, and it uses determinants. So I'm going to use a capital D, okay? And D is going to be the determinant of my coefficient matrix. So you could think about in a two-variable system, your coefficient matrix would be 2 by 2, the x's and the y's, and you could calculate the determinant. If it was a three-variable system, you'd have coefficient matrix 3 by 3, still square, so you could calculate the determinant. And remember, the determinant would just be a number, not another matrix. If you want to find the x variable for your system, your x variable is, and now I'm going to say d sub x divided by d. And we already know that, like, we've decided d is the determinant for matrix, coefficient matrix, which I would generally call like matrix A or whatever. So we're dividing by the determinant, whatever that number is, of our coefficient matrix. But then I have this other determinant that I'm calling d sub x. This is the determinant of the coefficient matrix when the x column is replaced with the constant. So in a matrix equation, you would have a coefficient matrix, matrix A. You would have the constant matrix on the other side of the equal sign, matrix B, and those are just like what your equations are equal to. Whatever those numbers are, you're going to take those numbers and put them in that first column where x's would be. But the rest of the coefficient matrix are the coefficients for y and the coefficients for z. And then you just do another determinant. Whatever you get for that determinant, remember, it's just going to be a number. So you're going to have a number divided by a number. There's your answer. So then y is equal to d sub y divided by d. So you would go back to the coefficient matrix. You would sub in the constants for the y column. You would leave all the other coefficients as is. If you have a three-variable system, you leave the x column and the z column alone. And you do another determinant. Divide by the determinant. If you calculate the determinant of your coefficient matrix first, you need to do additional determinants when you replace with the constants. Okay? And so this would go on for as many variables as you had. So if you had to find z, you would be doing d sub z divided by d. Okay? Let's see how that plays out. Okay, so we're going to start with quick and easy, two variables. So let's solve the system 3x plus 4y equals 1 and 5x plus 3y equals 9. Could write that as an augmented matrix and solve with row operations to get row echelon form. Could write that out as a matrix equation, A times X equals B. Find the inverse of the 2 by 2, multiply by B. We're going to solve by Cramer's rule, so we're going to do determinant. Okay. So my coefficient matrix is just whatever my X and Y coefficients are. So 3, 4 in the top row, 5, 3 in the bottom row. Calculate the determinant. This should be pretty quick and easy. That would be 9 minus 20, which is negative 11. And then after I have that determinant for my coefficient matrix, I can start solving for my variables. If I want to find x, I'm going to have to do a new determinant for x in my numerator, I'm going to divide by the determinant of the coefficient, which I've already found is negative 11. My new determinant for x, I'm going to take those constants, 1 and 9, and I'm going to replace them in my coefficient matrix where the x column is, the 3 and the 5. So I'll drop 1 and 9, but I leave y alone, 4 and 3. So the rest of the coefficient matrix stays the same, only one column should change. That's the variable that you're trying to find. Okay. Now I'm going to do another determinant on top. That would be 3 minus 36 divided by negative 11. That's negative 33 divided by negative 11, which is 6. So in my solution, I now know my x coordinates. Then I would do the same thing to find y. Y equals some new determinant divided by negative 11. I'm going to go back and reuse my constants, 1 and 9. But this time, I'm going to put them in for the y's, because I'm finding a new variable. Okay, so remember, in your coefficient matrix, your columns are the different variables. So we're going to put 1 and 9 in for y. And we're going to put the 3 and the 5 back in for x. Those are the regular x coefficients. So you only change one column in that matrix at a time. And then calculate determinant. 27 minus 5 divided by negative 11. That's 22 divided by negative 11. And that's negative 2. Oh. Questions about what I did? Yep, I have my ordered pair right here. Your solutions to systems should be represented as ordered pairs or ordered triples or ordered quadruples. Okay, so you could imagine maybe how this would translate to a 3 by 3 system, which will be on your test on Tuesday. Okay, so it's important that you feel comfortable with 3 by 3 determinants, because in order to do that for Cramer's rule, which will be on your test on Tuesday, you'll have to do essentially 4 3 by 3 determinants. Okay, so we'll do our coefficient matrix determinant together, and then we'll split the work in the room, and we'll have some groups do x, some groups do y, and some groups do z, and then you can get started on your homework assignment. So I would start with my coefficient matrix. I do not consider these numbers to be large enough to merit like being on the calculator portion. You can do 48 minus 15. So I'll get 33 minus 4, that's 29. Yell at me if you guys see a math error on my part. negative 26. Love 55. Okay, so we'll split up the work among the tables. I'll have this table over here, you guys find X. This table right here, you guys find Y. This table right here, you guys find Z, and you guys get pick your letter. Which one do you want to find? Okay, they want to find Z. So you guys should double check. Okay, so go ahead and just start talking to your group about how you're going to set up that numerator determinant. Make sure everybody agrees with the setup there.
I was going down.
Okay, what do we come up with? Equals 2, you then solid group. Okay, so checking in with groups around the room. we come up with for x, that determinant comes out to be 110 divided by 55, which is 2. For y, you get negative 165 divided by 55, which is negative 3. And then for z, you get 55 divided by 55, so that is 1. So you could write your solution as an ordered triple, 2, negative 3, 1. Now, there will definitely be Cramer's rule on the test because you won't have like a quiz or a problem set, so I need to see that you understand and know how to work Cramer's rule. And it will be on the no calculator portion of the test, so just be aware. I think earlier in the test, and I'll double check this before the end of the period, but earlier in the test there's another system you have to solve, but its directions will let you choose augmented or matrix equation because you've already done a problem set and a quiz, and I've already seen that you could do both of those. So then you get the choice, do I want to do the real operations and back substitute on no calculator, or do I want to find the inverse and multiply by constants? Okay, so just kind of be aware of that. Alright, so the rest of the period you have time to work on the assignment. We've got a nice chunk of 15 minutes so you can get some of that done.